Server-side rendering React in Ocaml. Server Reason React is an implementation of React DOM server and some of React's internals in Ocaml. Its purpose is to render HTML markup from the server for a Reason React application natively. This post provides an overview of some of the concepts of the library and what it means to render React in Ocaml, and how we use it at refs.com, a benchmark against Node equivalent, and the future of all of this. Ooh, it's kind of excited. Let's see how good it is against Node, because I have no idea what Ocaml can do. If you're not familiar with Reason or Ocaml, it's fine. The purpose of this post is not to convince you to learn or try those languages, but rather to share something I built that I'm passionate about. Okay. I will try to explain most concepts for any developer with experience in React. Don't be scared by any niche language technology mentioned here, since I'll introduce them as we go. The first piece of context to follow this post is to introduce Reason and Ocaml for those who are not familiar. Okay, so I know nothing about Ocaml other than TJ loves them. TJ is the biggest fan of Ocaml. It is right there. There you go. There we go. Okay, let's see. Okay, Reason is a language built on top of Ocaml. They share the compiler, the type checker, and most tooling around. It was created by Jordan Walke. Walke? Am I saying that right? Anyways, to allow JavaScript developers to enjoy Ocaml. Okay, I'm excited. Back in the days when TypeScript was not as popular, many members of the JavaScript community were interested in Reason. Ocaml is a type-safe and robust language that empowers a functional style with a powerful inference. I didn't realize Ocaml had types. I didn't think it had types. It's pronounced Wally. It provides a unique balance of performance, maintainability, and readability. Okay, see, that's how little I know about Ocaml. Despite being a niche programming language, Ocaml has made an impact on modern programming languages and language tooling. The first version of Rust were implemented in Ocaml and Meta's Flow JavaScript type checker as well. Huh. Okay. Nowadays, Ocaml is a solid option for general programming language backed by trade firms, blockchain, and SaaS companies. The 3 out of 4 writers of the apocalypse there, I see, is what writes them. Fintech, blockchain, and SaaS companies. Dang it. All right, refs. I'm a software engineer working on tooling. I work on maintaining the design system styled PPX. Let's see, helping the melange, and now the server React Reason. Refs is a comprehensive SEO tool set. Okay, let's just go to the problem. I want to read the problem here. All right. One of the initial problems with our main React application was that the client was client-side rendering. The canonical example of this problem happens on the header. We had to load a bunch of contextual data such as user, permissions, billings, tokens, and themes. Running all of those requests on the client creates a request waterfall. And often our users use more than one tool at a time, where navigating between those is not an optimal experience. Okay. Navigation would be slow, flashing the header for an entire, and the entire app while mounting each page. Time can be annoying and waste. Okay, so you guys see the idea here. We got some request problems. We got some waterfalls. They're gonna try to solve this, I assume, with server-side rendering, right? To address those issues, we implemented server-side rendering for our static parts, a shell app, and injected the data as regular scripts with serialized JSON, or GSML for short. We used TimeXML. TimeXML. Is that an XML library? A library that generates HTML from Ocaml. Okay. For creating these static templates. Okay. To improve the user experience by a lot, since the HTML served contains the static part of the app, so the browser can cache it locally, but we quickly encountered a new problem, having 2 separate implementations of the same component. Yes, this is such a problem with all of this stuff. The client version written in React and the server version written in TimeXL. TimeXL? I'm not sure how to say that. But this is real. This is real talk. Even in like a lot of the days, if you've been developing React long enough, like this is just a problem in general. You start getting these weird things where you start writing things twice because of just all the problems that are caused. Not easy to share implementations or even styles between the two. Keeping both versions in sync with different data requirements is too much hustle. Yeah, ensuring the server version of the component functioned correctly without data and the client one mounts on top with the interaction. The resulting tech was difficult to maintain, deterring developers from making significant changes. While the solution was adequate for some time, we sought a more scalable approach to our front ends. Okay. Hydration issues. Always hydration. Always hydration issues. To address some of those problems, Javi experimented to mix Taxmel, and Reason React with and published the experiment on his blog. Okay. In addition to server-side rendering with each request, we need a different strategy for our static pages, such as server-side generation, what Next calls incremental static regeneration, running a rendering step at build time, and populating state on each request. Okay. Ultimately, our goal was to use the same client components from our design system in these server templates. Okay, this is actually pretty interesting. This is a really good, I'd say this has been a really good kind of setup for the problem. Does everyone understand what's going on here? Because I'm very curious, how are they actually going to, it's using a bunch of terms, right? There's a bunch of terms that when people use in the front end world, I get confused. All right. Let's see, the first approach. The common solution to this problem is to go with a node-based solution such as Next.js, Gatsby, or Astro. Astro's pretty cool. Well, let's be real here. Astro's pretty cool. After using Gatsby and React Snap for a few years and a proof of concept with Next, we weren't satisfied with any approach. Love it. Pre-rendering SSG with Node. Running the pre-rendering step during the build and serving them via our backend in Ocaml. This solution couples the build process, running in a CI, with the runtime, the production, and staging servers. Increase the complexity on how we were serving those static files and how those static files became populated with data, known as hydration. Interesting. This just all seems really hard because whenever you're mixing, because mixing languages, especially when there's not because JavaScript's the only one with the full React support. So this mixing of languages just seems like it's so hard. I just assume this is so dang hard. And yeah, you create these templates, but still. Templates could be unsafe to hydrate and error prone. Yep, you need to generate templates for each language, currently 17, and upload them. Well, each language as in each spoken language? That must be a spoken language thing? That's tough. We don't do it like that at Netflix, but interesting. Running the pre-rendering on CI made a weird combination. Pre-rendering required to couple our Ocaml backend with HTML files and be aware of purging the cache. This sounds really hard. This sounds really, really hard. Running Node with SSR on production. The other solution is to serve applications by Node and using Ocaml as an API. Okay. Placing Node in front is a very common architecture that works wonderful in some teams, but there are still drawbacks when using Node in the backend for refs. So what he's saying is that you have an application that does, just to get this kind of correct in my head, I think what he's saying is that you have a client right here, you have middleware that is still Node, and then you have an API that it calls into that is Ocaml. They don't just substitute translations. In the one in the template, they make multiple templates. They make multiple templates, one for each language. Anyways, very interesting. I think that's what I'm saying. I think that's what I'm seeing here. Most of our APIs consist of fetching from different data storages and shuffle this data to serve it. Some of those problems make it not ideal for us. Single-threaded nature. Node.js inherently single-threaded, yes, which can lead to performance issues when dealing with high concurrency or CPU-intensive tasks. Yes, yes, and yes. Node.js isn't the best player at memory consumption. Oh, really? I just read in our previous article that JavaScript devs are very concerned about memory. All of a sudden, I'm looking right here, and I don't know. I don't know about this. You know what I mean? Seems a little suspicious. You know what I mean? Seems a little suspicious. SSR applications can be memory intensive, potentially causing resource constrained in production environments. Yes, this is real. You use a lot of memory when you use something like React on the server, right? I think this is going to be a really big problem with the upcoming push for everyone writing a bunch of JavaScript applications. All these serverless places, it's going to need a lot. Memory is just not cheap, and it's only getting less and less cheap all the time. Let's see, additional burden on DevOps as they're not happy learning another language and a framework to manage with the emphasis since it's an entry point for users. Type safety concerns. Ensuring type safety would be required, either using TypeScript and maintaining a separate type definitions or using Reason and compiling it to JavaScript. However, the Node.js's bindings aren't my favorite part of Reason. Okay. Let's see, might lead to some duplication of logic. Yep. Yeah, see, this all makes sense. You have two different problems. You have two different backends. You're going to have two different duplications. Logic switching a request from the server to the client or the other way around can be challenging, potentially leading to increased complexity. All right. So it looks like it's time. Think of the poor DevOps guy. We're just going to jump right down here. Entering server reason react. Reason react. The reason parser comes with the JSX transformations out of the box, so JSX expressions are compiled down to function calls. No need to use Babel, ESBuild, or Vite, or in reason. Oh, interesting. Is that because I assume that's because in Ocaml, there's some sort of macroing that's going on here, right? This little React component is some sort of macroing that's changing everything. Who is Jay and why is he sex? Oh, Jay sex? Yeah. That's how you say the name properly. That's cool. This is super cool. I think I could get used to that. I like that. I'm a little confused as what the syntax means because I don't see like a return statement. I see a semicolon at the end. So, if I apply my Rust skills, this is not returning anything out. Okay, but I like that. I love the idea that you don't have a build step for just a transpilation of the language, right? I love that idea. Reason and React are a set of bindings to the JavaScript version of React. So a tiny layer of the type system to tell the reason code the right interface of those hooks. Create element calls and any React API, similar to what .dts modules are in TypeScript. Okay. Or FFI in Rust. Okay, so what's server reason React? Server reason React is a reimplementation of React DOM server and some parts of React itself to generate markup from a React component, but written in Ocaml. More precisely, React DOM rendered a string in React. Okay. To make sure that React DOM can represent all kinds of nodes in React, components, elements, fragments, providers, consumers, there's a node variant. Okay, so this must be Ocaml we're looking at here. And so this is effectively a tagged union. Are we seeing a tagged union here? Is that what this is? Right? I don't really know what I'm looking at because I don't understand the syntax. This looks like some sort of function here. A function that takes in a unit, returns a node. This takes in a unit, returns a node. I don't understand what that list does right there. It's a Rust enum. Yeah, that's why I said tagged enum. Yeah. I kind of understand this. Okay. Cool. All right, they match with what React internally uses with symbols. The actual string generation is done by traversing the component tree and generating specific HTML representation of each node, and each node takes into account a few details, such as serialization, DOM processes, attributes, process, inline styles, and code HTML, and a few React particulars, such as dangerously set inner HTML. So I've always was curious about how React does that. So they keep it in a tree formation, and then they walk the tree and generate the string as it goes. Okay, that makes sense. A pseudo implementation of render to string to illustrate the mapping between components and HTML representation. Okay, we're going all in right now with Ocaml right here. All right, so render to string. This must be the argument. Match node with lowercase tags attribute when HTML is self-closing tag. Okay, there we go. So it's generating this string. Right here, tag attributes to string, tag attributes. Okay, so this must be a function call that takes in two arguments. That's how I kind of read this. And so it does each one of these. Okay. And then we recall render to string with component, goes back in here, and goes back through here. Text, it does a little text, inner HTML, okay, list, render to string, list. Okay. I think I understand that. List iter, I don't really quite get this. List iter must take in a function to call with the thing to iterate over. Is that correct? Did I get that correct? Okay. Cool. I feel like the thing is I haven't written any Ocaml, so it feels. I mean, reading a language can be kind of easy if you have something to think of, like if you have some sort of template to think of, and I kind of feel like it's supposed to be Rusty. Right? So, I figured this was a tagged union. I know functional style is really confusing. They love that kind of stuff. But I could learn to love Ocaml. I could learn to love it. To be sure, it supports full render and hydration the same way as React does. I migrated all tests. Oh, really? Okay. With all this solved on the server, the rest of React, such as hooks, portals, or any other APIs, were trivial in comparison. Okay. Most hooks do nothing. Use effects don't run. Use state is only setting the initial value. All states are ignored. Use callback creates a function once and probably never called. Use memo runs and gets the value. Yep. Okay, this all makes sense. Yeah, because on the server, it's a bunch of nothings. That totally makes sense. One difference with my implementation is about doing a single pass on the React tree while React.js does multiple passes. It's but it's on them to change it. Oh, nice. Nice. With all this done, we can return those strings as HTTP responses. Okay, benchmark. All right, this is where the juice comes in. This is what I'm very curious about. Does it win with the juices? You know what I mean? The juices. The main question I got while I was implementing was about performance. Yeah, the theory said that the compiled language Ocaml should overperform an interpreted one JavaScript. So you can't. The thing is that V8 is really amazing. And there's a lot of things V8 can do that are really amazing. You know, string concatenation is a great example. So in a more traditional language, you're going to be making memory allocations every single time, and you're going to have to reallocate and move things around. Whereas like V8, you got, rope strings, as we learned earlier. You guys, so it's a little different. It's a different world out there. So even when V8, the engine that runs on that Node runs on top of, is working tirelessly to optimize it, there's been many benchmarks to prove. But does it hold true here? My guess is no. I was curious too, but as I explained above, it was not the impetus. Impetus, did I say that word right? That's impetus, right? Impetus. Yeah, for reason React creation. In fact, the implementation isn't very optimized and not even profiled, but it does. But it does try to minimize allocations and CPU cycles, but there hasn't been any performance work so far. Okay. Impotence. Impotence is a little bit different. Plenty of React applications get a little impotent. I made a small micro benchmark before pushing the production to ensure there wasn't any regressions and prove how much we gain. How much gain we were talking against Node. Interesting. And bun solutions. Oh, and a bun solution. Okay, interesting. Apparently bun's quick. We compared the performance of these three stacks in terms of latency, requests per second, and transfer rate. Okay, I love this. Node.js with Express. Okay, requests per second, average latency, megabytes transferred. Bun. Okay. So 17, about double. So Bun is significantly better than Node is what we're looking at here. But requests per second, it's not like it's great. Reason server reason React, 64,000. So about 10x Node.js, just dominating the response time. 5x better average latency, 10x more requests per second, transfer rate out of this world. Wow. That's incredible. I am surprised. I am surprised by that much. V8 is magical. V8 is magical. Micro benchmarks do lie. Exactly. They do lie. I always forget how bad React is. Okay, so here's the deal. I forget about how bad React is. So I didn't put that into my calculations. When I played around with Leptos and did like Leptos versus React, it was like 100x faster using like a tenth of the memory. You forget about how bad React is when it comes to performance. React has never been built as a performance-first library. That is not the point at all. And so, it catches me off guard. All tests run on my MacBook. Okay, and the benchmark. Okay, so that's interesting. So he was doing. So I would like to see this done. My guess is he did this all locally. So I'd like to see this done non-locally. I'd love to see it put onto a server because it does make a big difference. When you're on a server versus when you're local, your applications do respond a lot different, right? I didn't realize it was going to be drastically different. Yeah, same here. Yeah. Python is the best. Oh, really? Okay. Status. It's deployed to all of our users since February and planning to use it on all front ends. Although it's not ready for consumption, the lack of documentation, the shape of the libraries, and some missing APIs make it hard to use, and I don't recommend relying on it. Okay. It's open source, and the repository lives here. Okay. This could be fun. Even with all of this, if you're still interested, feel free to contact. Okay. So what would be really cool is to create a solid version, right? Maybe Ocaml. Maybe I do need to start playing with Ocaml. Okay. So my general idea. Oh, okay. There's some more stuff. My general idea is that I do want my next project I do on stream after the interpreter is going to be trying to implement JDiesel. Okay. Am I a genius? Can I implement JDiesel? But then after that, maybe it's time to play with Ocaml. You know what I mean? It's working. Maybe I need to look into Ocaml. Okay, are you guys excited because I'm a genius and I'm going to implement JDiesel, or are you excited because I might be touching Ocaml? Ocaml, my camel. Let's go. Is it Ocaml or is it JDiesel? Which one is it? JDiesel? Ocaml? JDiesel? JDiesel? I knew it was JDiesel. Okay, it could be cool. Let's see what it enables. I got a little deep into some of the details about how it works with the curious minds, but the implementation doesn't matter much. What matters are the consequences. Same code for the front end and back end. The same code gets compiled to native and JavaScript thanks entirely to Melange. As far as I know, it can't be done in any other native languages such as Rust or Go. And let's see, there are many similar situations, but they don't cross-compile to the same code. Okay. That's super cool. That is super cool that actually works. It enables full-stack applications written in Reason. No matter, it's not a matter of one language to rule them all, but rather simplicity. I'm actually in full support for single-stack languages. Real talk, I'm in full support of single-stack languages, and it's one of the reasons why I've never loved Go, is because Go does not have the language complexity to describe what it takes to have a single-stack language. And it's also the big problem about Zig. Zig also does not have what it takes to be a single-stack language. But Rust does. And it seems like Ocaml might as well. So, yeah, Rust does. Rust has what it takes. Rust does. Rust, you can do a lot of cool stuff with Rust. Right? You know what I mean? Let's see. Simplicity on shared. So I'm curious about the debugging experience. The debugging experience, because the Rust debugging experience with WASM is sucks. Debugging WASM sucks. Real talk, debugging WASM sucks. It always sucks. Because you just get these arcane-looking things, and errors are weird, and you're just trying to get stuff out. Like, it does. But if the transpilation of Ocaml into JavaScript, and I can debug JavaScript, I wonder what that translation is in your head. If you're asking who Tom is, I personally would feel bad, okay? Don't ask who Tom is. If you don't know the genius himself, Tom is a genius. Tom is a genius. All right, performance is much better. Performance is critical for any SSR solution. Absolutely. That's been my whole problem. So this has like been my whole new React world problem, is that the new React world problem is purely this, that React is now becoming this like whole streaming React server components, React everything, building it onto the server, but it has abysmal performance, and you're really tied to providers right now. It's really just kind of like leaning into a lot of the serverless stuff, and it feels like it's going to be hard for a lot of places to adopt this. And so I'm very curious how this is all going to work out. What is the future of React and all that? So is this like a cool kind of like, hey, maybe you don't need that type of stuff? I'm so curious, right? I'm curious. Right? Not only the rendering engine itself, but the platform you are running as well. Not only the number of requests per second it supports or the memory footprint, but among many performance issues, one that stands out is the slow start. The slow start of a Node application is a barrier for current solutions. Now, often this problem is addressed by changing the architecture of your application by utilizing edge computing or a blocker to run SSR in development. Here's an example of the performance benefits of Ocaml. Ocaml-based frameworks are fast enough that you can boot for each request and tear down when a session finishes. On the other hand, this is much more challenging with Node. This is absolutely true. That's the whole cold start problem with Node. It is really, really difficult to do this. It is really, really difficult. Heard of the Bling project? No. By whom? By Tanstack? By Solid, Tanstack, and Astro? No. Weird. I'm in a Discord with them. I should just ask them. Yeah, I do think React has a lot of problems coming up. Allows for further exploration, of effects of React and Ocaml. React has been influenced by Ocaml and some of the functional programming concepts from the start, such as immutability, purity, and eventually algebraic effects. Create some of these base implementations for server components, which are a deal breaker for, allowing to only run components on the server and stream the output representation of it without the client-side penalty of executing the JavaScript code can change radically how we write our backends. Yep. Recently, Ocaml 5.0 was released with the highly anticipated features, multi-core and effects. These new features enable the possibility of exploring some of React's concepts to be written in Ocaml. Interesting. Huh. Huh. Maybe Ocaml's a little bit cooler than I thought. Maybe Ocaml is just slightly cooler than I thought it was. Okay? Maybe I've been wrong. Let's see. The main reasons why I would not adopt this today. It's an entire new ecosystem. New language, new package manager, new trade-offs. Okay. The learning curve might be big. The trade-offs made by Ocaml do not match with by some of the JavaScript or Node. Probably not as big as learning curve how to deal with the paro checker. Okay. See, that's okay. So this is what everyone says, that Ocaml is like Rust without the borrow checker. Is this true, TJ? Because real talk, all I want, no offense, I trust TJ. I don't trust you guys, okay? I know TJ is a good engineer, and I think you guys are a bunch of degenerates. So I just want a trade system and iterators. And then I would also love async iterators or some sort of push, some sort of like RX-like thing in the language. Right? That's really what I want. And of course, like a good typing system, enums, you know, tagged unions, all that. That's all I really want. You're not wrong. We are degenerates. Yeah, I'm not trying to be mean to you guys. I'm just saying, if Ocaml has, if hurtful but true, this man's out of line, but what he says is correct. TJ, it doesn't have a type class. Hold on, it doesn't have a type class in the same way, but it has things like that you can do. But in a lot of ways, you'll transfer your understanding of Rust to Ocaml easily. That's what I figured. Is that that's fair? I'm a bad engineer. Okay. Everything you asked for is in C#. Yeah, but then you have C#. I'm a very important person. I drive a Dodge Stratus. Yeah, the problem is you got that. Okay, and I don't want to do C#. Okay, I don't like Microsoft. All right, not everyone needs this at Rev, so we made it all, let's see, it made a lot of sense, but it may not, okay, I'm very excited. It's still experimental. It requires, let's see, it requires to lift the ecosystem to work on the server, so all client libraries need to be ported to Ocaml. Okay, or stepped. Okay, that makes sense. That could be true. Okay, so this is a real problem. Smaller community, but growing. Do we need to blow up this community, degenerates? Okay. Okay, so arguably Ocaml is simpler than Rust. Don't send the DGen army. Why not? I mean, then I can't do it on stream because the moment I start doing it, I've been wanting to find a technology that I'm excited about writing full stack applications in. Okay, because I'm so tired of JavaScript. JavaScript is just. People always be like, dude, you know, you can't, why are you always talking bad about it? Why don't you just like, you know, just fix the things that are wrong? You can't fundamentally fix these things, okay? And it's like coming down to PHP, Laravel, all right? Am I going to do Laravel, or am I going to do full stack Rust, or are we going to do full stack Ocaml? Leptos is beautiful. I love Leptos. Real talk, Leptos is one of the best frameworks ever out there. You mentioned you tried Elixir. I don't know if I want to do Elixir. The types really hurt me. I hear great things about Laravel. Everyone says Laravel is amazing. Just don't make full stack frameworks. That's fine. The thing is I've just been wanting to try something to do that, right? And so I've just been on this language exploration for the last year because I really want to like make the right decision. You know what I mean? Real talk. I've been trying to make, like, I've been really trying out a bunch of languages. Like, you guys have been here for this adventure. And so, like, reading this does get me excited, you know? I think some of the tooling stuff is better in Rust, though. Yeah, that's fine. Just to be aware. The situation is getting much better for Ocaml in the open source space, even in the last 6 months. Okay. I mean, I'm programming with Zig currently on stream. Have you seen the tooling in Zig? There we go. Stop that a while ago, Flip. Stop it a while ago. The name is the Primogen. All right.